You know that feeling when you hit the gas and there's just nothing? I had that last week merging onto the highway. Felt like I was pedaling a bicycle, seriously. That frustrating hesitation that makes your car feel sluggish and immediately sends your mind to expensive repair bills. Well, what if we told you there's a common culprit and the fix might be completely free, something you can do yourself in just minutes?
It's absolutely true. Today, we're taking a deep dive into what is essentially your car's brain specifically. How to reset its throttle position sensor, or TPS. We've got 3 distinct DIY methods for you, each tailored for different situations, so you'll walk away knowing exactly which one applies to your vehicle. Our mission: to empower you with knowledge, potentially save you a significant chunk of change on mechanic bills, and maybe even rediscover how much fun your car can be to drive.
Okay, let's unpack this then. Get your car feeling responsive and ready to go again.
Right. But before we jump into the how, it's probably worth a moment to understand the why. What's fascinating here is that the TPS acts like a crucial translator between your right foot and your car's engine. It constantly tells the car's computer, the ECU, precisely how far you've pressed the gas pedal.
So it's essentially taking my physical input, my foot movement, and turning it into a digital command for the engine, like, hey, more power, or ease off.
Exactly. Think of it as the direct line of communication for engine power demand. But here's where the problem creeps in over time, with just normal wear and tear, and especially with carbon buildup inside the throttle body.
Ah, the gunk.
Yeah, that's where the air enters your engine. This sensor's baseline closed position can subtly drift. It's a bit confused. The car's computer might then mistakenly believe the throttle is slightly open when it's fully closed, or maybe vice versa. This tiny miscommunication is often the root cause of that annoying hesitation, or a rough idle, or maybe those weird engine revs you might be experiencing.
So a reset is like telling the car, hey, forget what you thought you knew about the throttle position. Let's start fresh with the correct settings. But why wouldn't the car's computer just adjust on its own over time? Doesn't it have adaptive learning?
That's a really good question. And you're right. Modern ECUs do have adaptive learning. They're constantly adjusting to your driving style, engine conditions, all that stuff. However, there are limits to that adaptation. When the TPS drift becomes too significant, or, like we said, carbon buildup physically alters the throttle plate's resting position, the ECU's learned values can become so far off that a simple adaptive adjustment just isn't enough anymore.
Okay, so it gets overwhelmed.
Exactly. You're essentially forcing the computer to ditch the old, incorrect data and relearn the sensor's true 0 point and its full range of motion. It's kind of like recalibrating a digital scale, right? To make sure it reads 0 before you start weighing anything. It gives the ECU a known good starting point for its adaptive learning. It's a fundamental electronic handshake that can make a world of difference.
All right, makes sense. Let's start with the simplest approach we found then, the basic key turn reset. This sounds like it's often your first line of defense for most modern cars, especially if your vehicle just feels sluggish, the throttle isn't responding crisply, or the engine is revving weirdly. But, and this is key, you have 0 check engine lights on the dash. Walk us through it.
Absolutely. And the key here really is precision and patience. Don't rush it. 1, first, make sure your car is completely off, parked safely, and the key is out of the ignition. This ensures the ECU is in a neutral state, ready to receive new information.
Okay, car off, key out, check.
2, next, put the key back in, but don't start the engine. Just turn it to the on position where all your dashboard lights illuminate. You'll see the system powering up.
Right, lights on, no engine.
3, now slowly and smoothly press the gas pedal all the way to the floor. We're talking a deliberate, maybe 4-second push until it can't go any further. This tells the sensor is full travel range.
Slowly down, 4 seconds.
4, once it's down, hold it there for a solid 3 seconds. No pumping, just hold steady. This lets the ECU register that maximum open position.
Hold for 3, got it.
5, now, just as slowly as you pressed it, release the pedal. Let it come all the way back up over about 4 seconds. This registers the minimum closed position.
Slowly back up, 4 seconds.
6, and this is crucial. You need to repeat that entire press, hold, release process 2 more times. So a total of 3 repetitions.
3 times total.
Yep. Skipping a step or doing it too fast will make the whole thing pointless, as the ECU needs to see this specific pattern multiple times to accept the new calibration.
Right, gotta follow the sequence.
7, after you've done it 3 times, turn the key to the off position and pull it out. Give it about 10 seconds for the system to settle.
Key off, wait 10 seconds.
8, for the final check, put the key back in and start the car. Pay close attention to how that gas pedal feels now. you should hopefully notice a sharper, more direct connection.
So if you feel a more responsive pedal, you've basically given the ECU a gentle reminder of the TPS's proper range. It's pretty amazing what a simple calibration can do sometimes.
It really is. This method helps the ECU reestablish the basic range of the TPS, often clearing those minor learned quirks or temporary inconsistencies. Think of it as a quick mental refresh for the car's throttle system.
Okay, so what if that first key turn trick didn't quite cut it? What's the next course of action? Where do we go from there?
Right, if method 1 doesn't yield the results you're looking for, then our sources indicate the battery disconnect method is your next logical step. This one's especially relevant for cars with electronic throttle control systems, which is most cars these days. This isn't just a simple reset like the key turn, it's more like a hard reboot. It clears a broader range of the ECU's adaptive learning values, particularly things related to idle and fuel trims.
Okay, sounds more thorough.
It is, but a quick word of warning here. Safety first, always.
Absolutely. Safety is paramount when you're messing with car batteries. What should listeners keep in mind?
Okay, number 1. Always disconnect the negative terminal first. That's usually the black cable. Mark with a minus sign and reconnect it last. Super important sequence.
Negative off first, negative on last. Got it.
Make absolutely sure your metal tools don't touch both battery terminals at the same time or touch the negative terminal and the car's frame or body. That's a recipe for sparks, maybe frying electronics, or worse.
Good point. Short circuits are bad news.
Yeah, if you have them, wear some gloves and safety glasses. It's just good practice. With those crucial safety notes in mind, here are the steps. 1. With the key out of the ignition, pop the hood and locate your battery. Easy enough. 2. Use the right size wrench to loosen the nut on the negative terminal. You don't have to take it all the way off, usually just enough to wiggle the cable connector free.
Just loosen it enough to get the cable off.
Exactly. 3. Once it's loose, carefully lift the cable off the battery post and tuck it somewhere safe where it absolutely cannot accidentally touch any metal parts. This isolates the battery completely from the car's electrical system.
Tuck it away securely.
4. Now you play the waiting game. Leave it disconnected for about 5 to 10 minutes. That downtime is critical. It's giving the vehicle's electronic control unit, the ECU, a full chance to purge its temporary memory, its RAM, basically, and drain any lingering residual electrical charge. This ensures a true, comprehensive reset.
5 to 10 minutes. Patience is key again.
It is. 5. After the wait is over, go ahead and reconnect that negative cable back onto the post and tighten the nut. Don't go crazy with it, just snug is good. Over-tightening can damage the terminal or the cable end.
Snug is good.
6. Get back in the car, put the key in, and turn it to the on position. But again, don't start the engine just yet. Let the dashboard do its self-check for maybe a minute. This allows the various electronic modules in the car to reinitialize properly after the power loss.
Key on, let it think for a minute.
7. Finally, start the engine, but don't touch the gas pedal at all. Let the car just sit there and idle for 10 to 15 minutes.
And 15 minutes of idling. Why so long?
It's super important because it allows the ECU to relearn the engine's baseline idle parameters from scratch, establishing a stable idle speed and air-fuel mixture without any driver input interfering.
Okay, so it's learning its new normal idle.
Precisely.
Right.
8. After its little learning session, turn the engine off, then start it back up and see how it feels when you drive.
That's definitely more involved, but it sounds like it gives the car a much more fundamental fresh start by wiping the slate clean on a lot of those learned values, not just the TPS range.
It does, yeah. And it often helps reset a lot of learned values that the first key turn method might not touch, like idle control and fuel trims. However, it's still not a silver bullet for a physically failing sensor. If the problem persists after doing this,
then it might be something more serious.
Exactly. Which points towards a deeper issue, and that leads us nicely into our third option.
Okay, so method 3. If the first 2 methods failed and you're still dealing with throttle issues, or perhaps you've just cleaned or even replaced your throttle body entirely, our sources indicate this third and most advanced method is your heavy hitter. This is the one for persistent TPS-related trouble codes or when nothing else seems to work.
It is, but this is where we need to introduce a serious word of caution. Really pay attention here. If you're not 100% sure the sensor or the throttle system in general is the problem, or if you're just not comfortable with this level of procedure, it's probably better to pause here. Don't just dive into this if you suspect a deeper issue like a vacuum leak or a fuel delivery problem.
So diagnosis is key before trying this one.
Absolutely. Knowing the symptoms, maybe even having scanned for codes, can save you a ton of time and help you decide if this is really the right move. Also, this procedure has some pretty strict conditions. Your car battery needs to be in good shape and fully charged, and the engine must be completely cold for this to work properly. Don't try this right after a drive.
Wow, okay, those are some specific requirements. What's the thinking behind needing a totally cold engine and a fully charged battery for this specific method? The others didn't mention cold.
Yeah, excellent question. A fully charged battery ensures stable voltage throughout the entire recalibration process, which is absolutely crucial for sensitive electronics performing a detailed relearn. Any voltage fluctuation could mess it up. And a cold engine is vital because the ECU uses various engine temperature inputs, coolant temp, air temp, to establish the correct initial idle parameters in fuel mixtures for a cold start. If the engine is already warm, those initial learning values will be skewed right from the beginning.
Ah, so it needs that cold start baseline.
Exactly. This method aims for a true factory-level relearn, and you can really only achieve that properly from a completely cold start. So here are the steps based on the information we've gathered. 1. First, using your wrench, disconnect the negative battery cable again. But this time, just wait for about 2 minutes. This ensures a minimal power cycle, just enough to reset certain flags. Then reconnect it securely.
Disconnect, wait 2 minutes, reconnect.
Okay. 2. Now turn the key to the on position without starting the engine. Just like before, dash lights on.
Key on, engine off.
3. And this is the interesting part. Crucially, get out of the car and listen closely near the front of the engine bay, near where the air intake goes into the engine. You should hear a faint buzzing or maybe some clicking sounds coming from the throttle body itself.
Buzzing or clicking, what's that noise?
It's a strange little electronic symphony, almost like a tiny robot doing its morning stretches in your engine bay. That's the sound of the electronic throttle plate actually moving, calibrating itself, learning its absolute minimum and maximum physical positions without any engine vacuum or airflow interference.
So it's physically finding its limits.
Precisely. 4. Be patient. This calibration noise can take anywhere from, say, 3 to 5 minutes depending on the car. Don't interrupt it. Once the noise stops completely, the calibration is done.
Wait for the buzzing to stop. Could take 5 minutes.
Yep. 5. Turn the key to off and remove it. You're almost there.
Okay.
6. Start the engine and, just like in the previous battery disconnect method, let it idle undisturbed for about 10 to 15 minutes to fully recalibrate the idle speed control. Again, don't skip this. It's a critical step that allows the ECU to establish baseline idle fuel trims and air-fuel ratios based on the new throttle calibration.
Idle again, 10 to 15 minutes. Got it.
7. Finally, take the car for a short test drive. Pay attention, make sure the throttle response feels smooth and predictable across different RPMs and loads. This is the most comprehensive relearn, aiming to reset all learned values related to the throttle and get everything talking properly again.
Okay, that sounds like the most thorough reset possible without specialized scan tools. Now that you've potentially reset your throttle position sensor using one of these methods, you'll definitely want to make sure the problem doesn't just come right back. What's the best offense here? How do we prevent this drift?
That's thinking ahead. The best way to prevent this issue from recurring, based on our findings, is really straightforward. Keep the throttle body itself clean. Over time, as we discussed, carbon and oily gunk build up inside from the crankcase ventilation system and exhaust gas recirculation. This buildup can physically restrict the throttle plate movement or coat the sensors, messing with the readings and making the throttle plate stick slightly.
So cleaning prevents the physical cause of the drift.
Exactly. As a general rule of thumb, it's a good idea to inspect and potentially clean it maybe every 20,000 kilometers or so. But always, always check your car's specific service manual for the recommended interval. Prevention truly is better than cure here, saves you hassle down the road.
Makes sense. So a little preventative maintenance goes a long way, but I imagine you can't just spray any old degreaser in there, right? Are there any special considerations for cleaning? What should people use?
Oh, absolutely, and this is crucial. Please listen carefully here. Never, ever use aggressive chemicals like carburetor cleaner, brake cleaner, paint thinner, or gasoline on a modern electronic throttle body.
Why not? They seem like strong cleaners.
Because they're too strong. They will destroy the special low-friction coatings on the throttle plate and bore, and they can damage the delicate electronic sensors and plastic components inside. These aren't simple old-school carburetors anymore. Instead, you need to use a product specifically designed for the job, something labeled like throttle body cleaner or air intake cleaner. CRC makes a popular one, for example. These cleaners are formulated to be tough on carbon and varnish buildup, but chemically safe for the sensitive coatings, plastics, and electronics. It's what the pros use, and it's definitely what you should be using too.
Okay, specific throttle body cleaner only.
Right. Using the wrong cleaner can genuinely create a much bigger and far more expensive problem than just a hesitant throttle. It's like using, harsh industrial cleaner on your laptop keyboard. You just wouldn't do it.
Good analogy. Okay, look, these reset procedures sound like fantastic tools to have in your back pocket. They can potentially fix minor response issues and certainly save you a trip to the shop, maybe some money. However, we have to acknowledge they aren't magic wands, are they?
No, definitely not. That's a really important point to make. If your problem keeps coming back after a reset, or if the symptoms are getting progressively worse, or honestly, if you simply don't feel comfortable performing these steps yourself, there is absolutely no shame in getting professional help. None at all.
When do these resets just not work?
Well, these methods won't fix a sensor that has a physical internal failure, like a worn-out resistive track inside the TPS. They won't fix a problem in the wiring harness connecting the sensor to the ECU, like a frayed wire or a corroded connector. And they won't fix a mechanical issue with the throttle body itself, like worn gears in the actuator motor.
So underlying hardware problems need hardware solutions.
Precisely. Persistent problems or the presence of specific diagnostic trouble codes, DTCs, related to the throttle system that just won't clear after a reset are a very clear sign that you need a proper diagnostic scan from a qualified technician with the right equipment. Don't be afraid to consult a reputable shop or a mechanic you trust. Sometimes, knowing when to stop DIYing and call in the experts is truly the smartest move you can make. It's about respecting your own limits and ultimately ensuring the car is safe and reliable to drive.
That's great advice. So we've taken a pretty deep dive today into something that might seem small, this little sensor, but it can have a huge impact on how your car drives and, frankly, how much you enjoy driving it. From a quick key turn trick to a more involved battery disconnect and even a full system relearn, you now hopefully have the knowledge to tackle a sluggish throttle response yourself, maybe prevent future issues with some cleaning, and crucially, know when it's time to call in the pros.
Absolutely. What's really fascinating here, I think, is how much control you can actually have over your vehicle's performance and feel with just a little understanding of how these systems work. Empowering yourself with this kind of knowledge not only potentially saves money, but I find it also builds a deeper connection with your car. You understand it a bit better.
And that's really what we're all about here at the Deep Dive, sharing that understanding.
Yeah. And, given how crucial a properly calibrated TPS is for both performance and fuel efficiency, it makes you wonder what other seemingly small, often overlooked car components might be silently costing us performance or money without ever throwing a check engine light. Something to think about for next time, perhaps.